In this video, we're going to learn about different types of set, Cantor Diagonalization Argument and Multiset. Different types of set. Very first type of set is bounded and unbounded set. As name suggests, bounded set is a set which is bounded by some boundaries. A bounded means it has certain sense of finite size. Finite size means what? If endpoint exists or range in which your set elements exist is known, then that is called as a bounded set. But for bounded set to be, we should have both the boundaries. Means you should have both lower bound and upper bound. What is meaning of that? Means you should have both lowest value for that set and both next what is the largest possible value for that set. Then that set will be bounded set. The lowest possible value for that set is called as infimum, or we can say that least minimum value, and the largest possible maximum value for that set is called as a supremum. So that is also called as the least maximum value for that set. For example, this set closed interval 2, 403 open interval. What is meaning of this set? That your set will have element consisting of 2, 3 and so on, but the last element will never be 403. It will not include this element but lesser value than that of 403. So your element will be 2, 3 and so on to 402. So this is bounded set because I can say that 2 is the smallest value and 402 is the largest value for my set. Exactly, the number is present for the smallest or largest value. But in some case, if the number is not present, then we should have some kind of range. So for another example is that we are having the set that is 1, 1, 2, 1, 3 and so on. So in this case, what we can see that our number is going from range of 1, 0.5, 0.3, so and so on. But the next largest or nth element will be 0.000000 and some number. So our set range is lying from 0 to 1, so this set is also bounded. The same as that with the 1 by n, the set is also bounded. The set 1, 2, 3, 4, this is unbounded set because I don't know what is the nth value. I don't know from 1 to what particular element my set will go. I don't know the range, so this will be unbounded set. The same with this set. I don't know what is the smallest value for this set and what will be the largest value for that set, or either what is the maximum smallest value or maximum largest value for this particular set. So this is unbounded set. The next type is countable or uncountable set. A countable set is a set in which you can surely say what is nth value, then that will be countable. In other sense, we can say that a set is countable if it is finite or there exists one-to-one correspondence. One-to-one correspondence means I can say that first value, second value, third value and nth value can be countable in your set, then that will be countable. For example, set of vowels. In that I can say there are 5 elements, they are finite, they are fixed number of elements, and for time being I can say this is first element, second, third and so on. Suppose this is the list of a set in which positive integer 1, 2, 3 and so on. I can't say what is the largest value present for that set. No. But if someone tell me that find out 100th number in this set, I can easily find out 100th number in this set. Means at least I am getting some value for that thing. So that will be countable. Your nth value you can count, but how many n are present you can't count. So this is countable set. But both you cannot be able to find how many number of elements are present, what is nth value, what is 100th value, then that set will become uncountable set. Again, for this thing uncountable set, there exists a theory which is proved by Cantor, that is Cantor Diagonalization Argument. Your set is finite. Again, in countable set, if you can easily say that what is nth value, what is 100th value, what is 50th value in your set, then again in that set also you can have two categories of the set. If your set elements are fixed, number of elements in your set is fixed, then that is called as a finite set. And if the number of elements in your set are unknown, then that is called as an infinite set. Cantor diagonalization argument. It is also called as a Cantor's diagonal argument, diagonalization argument, the diagonal slash argument, the diagonal method. Why this is used? He has used this proof to he has used this mathematical proof to show that there are infinite sets uncountably which cannot be put into one-to-one correspondence with the infinite set of natural number. Meaning of that, I cannot say in real number set what is first value, second value, third value and fourth value and so on. So we have to prove that all reals are uncountable. To prove this, we have Cantor assume set of real number is countable. If something is countable, first value, second value, third value is measurable. So we will suppose if countable x1, x2, x3 are present, and so on. As we can't count all of the possible values, so we'll just write down some small number of some of these numbers. Okay, so we have just written randomly, we have picked any real values and we are just picking subset from 0 to 1. What are the real values? We just took subset of all real set, and from that also 0 to 1 number we are just taking out some real numbers. These are real numbers. Now if this is countable according to assumption, now this list will going to exhaust, or this list will going to end at some particular numbers, and it will include all the possible numbers in this list if this is countable. Okay, and there exists one-to-one correspondence from natural number to real number. Meaning of this is what? Means I can easily map what is the first number in my set, what is second number in my set, what is third number, fourth number and so on. To disprove reals are countable, we have to make some contradiction. For making that, what we will do or we will create our new number. No matter how long this list goes, you will still miss some number. This is our final thing we have to prove. So for that, we are just creating our new number. And how we are creating our new number? And how we will create our new number will be such that which is not in the list. But for that, we have to pick out some numbers from the list numbers. So what we are doing, we are making a criteria. We are just picking the diagonally all the numbers after decimal point. From the first element, we are just picking first element after decimal point. From the second element, just pick second element from the after decimal point. From the third element, just pick element after third element after decimal point, and so on. So what number we will get? That it will be 0.37210. But this will never be different from our taken list of the set. So to make it different, we should perform some mathematical operation. Okay. So what we will do, let's add 1 in each decimal digit. So the new number we will get, that is 0.48321. Okay, now this number will surely give us guarantee that the first decimal place will never be same as that of first element. Okay, now the second place decimal place will never be same as that of second element second place. Now this will surely give me guarantee that now this number will never be same as that of third element, because its third place is different from the third element. Any nth number will never be same, so this number will be very new. So what we have proved that every decimal is different from each number. No matter how long this list goes, still what we are doing, we are having some new elements which are not in the list. Means you will miss some number, our new number which is not in the list. So this is proving our theorem. Now, if we are having n element from the natural number, first, second, third number, okay, and these are the real numbers. Nth number can be anything, but whatever numbers we are having from the real numbers, we can always get a new number from that combination, and which may be n number of numbers. So if these are n numbers, this can be n plus any number. Means what we can say that if this is infinity, this is also infinity, but it doesn't make any sense. In simple word, we can say these numbers are countable. First number, second number, fourth number, 10th number. Okay, this is countable. But can you count what is this number? Which is this number in the list? Whether it's 100th number, 10,000th number, or which number? I can't say. I can't count. Again also, this natural number set is less than real number in how much sense, whether it is twice, this real number set is twice or 10 times bigger than natural number, we can't predict. So we made a conclusion from this that this natural number set is countably infinite and real number set are uncountably infinite set. Okay. Now the different types of sets are empty set or null set. A set in which there exists no element, that is called as an empty set, and that is always represented by a phi. The cardinality of that is 0. Equal set, if two sets are having same number of elements, then that set are called as a same set. Here in both set we are having exactly same elements and that is also having same number of elements. So this is equal set. Equivalent set, if two sets are equivalent sets if their number of elements are same but their elements inside the set are not equal. Now this element is not equal to this element but number of elements or cardinality of both the set is same, then that is called as equivalent set. The next is overlapping set. If two sets are having some result in their intersection, means at least one number is common between these two sets, then that is called as a overlapping set. Singleton set or unit set, if your set is having only one element, then that is called as a singleton set. Universal set, a universal set contains all the elements of problem under your consideration. Whatever problem you choose for that, whatever largest set you have, that is called as a universal set. Power set is a collection of all subset of a given set. Now for example, I am having set A which is having only two elements. Now if I am try to go for making combination of this element, I will get 0 element combination, 1 element combination, all the elements combination. So this will be my resultant set. Now from this we can conclude that if you are having m element in your set, then there will always be 2 to the power m element in your power set. Now this is some tricky example. Set B is having 3 elements and in that second element is set, third element is also set, but for calculation of power set we never assume this as a set. We never go again perform, we never divide this set into two parts or different parts and then perform power set on that also. Instead of that, what we just do, we just assume that this is a kind of label, this is a kind of label, or this is a single element, this is also single element, and depending on that we do combination and the result will be our power set. So the combination, 0 element combination will be 5, 1 element combination, this 3 elements, 2 elements combination, these are the possible numbers, and all 3 elements combination. So for 3 elements in set you will having 2 to the power 3 elements in your power set, means you are having total 8 number of elements in your power set. Subset and superset, a set is called as a subset. A set A is a subset of set B, or equivalently B is a superset of A when A is contained in B. Multiset or bag or M set. A multiset is a collection of well-defined and unordered objects. Now here you can see that it's a collection, but in this collection you are having some colors are getting repeated. So they are getting repeated multiple times. So we can say that we don't have any unique object. We have some properties, these are well defined, okay, these are colors, but they are getting repeated. So redundant representation of set is multiset. It is modification of concept of a set. Multiplicity of an element may be one or more. And what is multiplicity? Multiplicity of an element is that how many times that element is appearing in your set or multiset is called as a multiplicity. The collection of number 1, 1, 2, 2, 3, 4 is multiset because no matter how many times that element occurs, we will still take that into the multiset. So this is appearing twice, this is twice, okay, this is a multiset. Now the collection of number 1, 2, 3, 4, this is also multiset, but this is also a set. Now again A, B, B, B and C, this is a multiset. Why? Because the elements are appearing multiple times, but this cannot be set. Set says that the element should have well-defined property and they should be distinct. But here B is appearing 3 times, so it is not distinct. So that's why it is not a set. The same property multiset has as that of your set. It has elements. It is denoted, set is denoted by capital letter, members of set is denoted by small letter, belongs to, doesn't belongs to operator used on multiset, and each object of multiset is called as an element or members of multiset. So what are different operation we have on multisets? There are basically 6 operation we have on multiset. First is multiplicity. The multiplicity, this operation is performed only on element inside the multiset. Okay. And what is it? It is how many times that element is appearing. Multiplicity, for example, in this set, multiplicity of L means how many times L is appeared in your set. That is 2 times. So multiplicity will be 2. Union of 2 multiset will be maximum of multiplicity of element in between any of the 2 set. Means from this 2 set, which is the maximum occurrence of that particular element. Here L is appeared twice, here L is appeared 1 time. So this twice appearance is more. So always we will try to pick maximum repetition of that element, and that will be our result. In opposite way, intersection will be minimum of multiplicity of element in between any of the 2 multiset. Okay. Now in these 2 sets, what we can say, here L appeared twice, here L appeared 1 time. So this is smaller appearance, or this is minimum multiplicity of my L. So this will be added in our intersection result. Again, the next thing is that here, if you notice that this symbol is represented by A intersection B. Again, if you'll notice that here you are having X appeared 1 time in set A, but here X is not appear. Means it is having multiplicity as 0, means 0 time X is appeared. So that's why 1 and 0, which is smaller value, that is 0. So that's why we have not written X here, because 0 time X appear means it is not appeared. So X is not written in your result. In the same way, next multi-set operations is cardinality. Cardinality is same operation as that of your set. Means how many numbers present in your set, no matter whether they are repeated. But exactly we will need to count how many numbers of element present in your set. That is called as cardinality of your set. Sum is summation of all the repetition of your number from both the set. That is sum of your multi-set. And difference, in this difference, this is tricky one. Difference of multiset is difference between multiplicity of first set minus multiplicity of second set. Again, in this also, if first set element is having less multiplicity, or in some in other case we can say that this is appeared only 1 time, less time, and this is appeared twice time, 2 times. So 1 minus 2 is minus 1, but we never write that. So instead of that, we write that L is appeared 0 times. So this will cancel out. M appeared here 1 time, here M is appeared 1 time. This will be get cancelled in our result. A minus B. Okay. Now L is cancelled. M is cancelled. N minus N. Okay. Now here N, we should have to consider only 1 repetition. We cannot consider this. So this will cancel out our N. Again, P will be get cancelled and R will be get cancelled. So we will be remaining with the 5, means null set.